Okay, and we're back with the second half of chapter 10, day 1, and this is just using those vocabulary words and then algebraically figuring out some lengths and distances based on what the segments are actually doing in relationship to the circle. So, last time I told you we are going to have to remember how to FOIL or multiply, things like that. Well, this time you're actually also going to have to apply what that bell work, like the beginning of class stuff that in the last video that we did, and actually apply it to solving equations. So let's go ahead and review a couple of examples on how to do that. This might look a little intimidating with a lot of x squareds and things like that in there, but it's not that difficult. Okay, so I have x squared plus 27, and then on the other side I have x plus 3 squared. So before we start solving, we're not going to take any square roots of anything or anything yet. We need to take care of this x plus 3 squared and put that all the way out in multiplied out form. So this x squared plus 27 is just going to stay the same over here. And then we're going to multiply x plus 3 squared, which last time I showed how to do one of these, I did the box method. So this time I'm going to show you how to do it by doing double distribution or FOIL. X plus 3 squared is x plus 3 times x plus 3, which is going to be x squared plus 3x plus 3x, oops, plus 9, because 3 times 3 is 9. So I'd have x squared plus 6x plus 9. So the other side of my equation is going to be x squared plus 6x plus 9. Okay, so now our goal is to get x all by itself, so I'm going to go ahead and subtract x squared from both sides. That's going to get rid of my x squareds. Then I'm going to subtract my 9 from both sides. 27 minus 9 is 18. And then I just have 6x left over here. If I divide out my 6, I get that x equals 3. See, it's not so bad. All right, this one looks similar. It's a little bit different. I'm not quite sure why it says dA up here. That should not be there. Okay, so again, I have x squared plus 15 squared. Well, I do know that this is just a number. X squared plus 15 squared is 225. And then x plus 5 squared. I'll box method this one, so we have an example of each. I have x plus 5 on one side and x plus 5 on the other. So I end up with x squared, 5x, 5x, and 25, which is x squared plus 10x plus 25. Again, I'm going to subtract my x squareds from both sides, like so. And then I'm going to subtract my 25 from both sides also. And I get 200 equals 10x. If I divide both sides by 10, I get that x equals 20. All right, let's move on. All right, so here's the two big ideas that we're going to be looking at today. First, okay, is the idea that if you have a tangent line, okay, so this right here is in blue is the tangent line. If you have a tangent line and a radius, which is what's in red, they will always be perpendicular to each other. Okay, that's how they work. So if you have a tangent and a radius, they are going to be perpendicular to each other, which kind of goes back to last lesson yesterday or earlier, where you can draw in a hypotenuse and then you can figure out some lengths of things using right triangles. So that's the first idea that we're going to do, is a tangent line and a radius. And then the other idea is we have these two tangents that are on the outside that meet at this point out here. So I have this tangent line, and we could extend the tangent if we wanted to, but it intersects here and here. And if these two tangents intersect at a point outside the circle here, that basically means, let me erase my messy lines here, that basically means that these two segments are going to be equal to each other. So RS is going to be the same as ST. So that's, if you have two tangents, they're going to be equal. If you have a tangent and a radius, they're going to be perpendicular. Okay, so first we want to figure out, is ST tangent to circle P? Well, if it is, okay, in order for it to be tangent, that must mean that we have a right triangle. So we need to figure out, is this a right triangle or not? So we have a leg and a leg, okay? So we would have 12 squared plus 35 squared, okay? Because remember, this is the Pythagorean theorem. If it's a right triangle, okay, equals 37 squared. So let's check and see if that's true. Okay, so 12 squared is 144. You're going to probably need your calculator. 35 squared is, what is that, 1225? And 37 squared is 1369. So if we put those two together, I believe we get 1369 equals 1369. So since the Pythagorean theorem is true and they equal each other, that means that yes, it is a right triangle. And that also means that yes, it is tangent to the circle because it is a right triangle. Okay, so here we have two tangent lines, okay, meeting out here at point R. If we have these two tangents, that means that this segment and this segment are going to be equal to each other. So this one's not so bad. So we just know that whatever one is, 3x plus 4, it's going to equal the other one. So I'm going to go ahead and subtract 4, and I get 3x equals 24. So I know that x equals 8. All right, this one looks a little bit trickier, doesn't it? Looks a little bit like the ones that we did in the beginning of the lesson video from the last time. Okay, so we know it is a point of tangency. Okay, it tells us that in the directions, which means that is a right triangle. Okay, so we know it is a right triangle. So let me zoom in here. I'm going to put my right triangle here, which means I also know that here's my legs, here's R, or my A and B values, and then my hypotenuse. So in order to find R, I'm going to have to use the Pythagorean theorem. I'm going to have to say my legs, which are the two red ones, are going to be R squared, R squared plus 80 squared is going to equal the whole blue segment, which is R plus 50. And remember, the Pythagorean theorem says that we square that, okay? So why don't you pause the video, okay? I want you to actually go through and see if you can solve this on your own, and then once you're done pausing the video, then you can start it again and you can see if you are correct. Okay, so as you go through, we should have squared here. We've got R squared, 80 squared is 6,400. R plus 50 squared is R squared plus 100R plus 2,500. My R's are going to cancel. If I subtract 2,500 from both sides, I get 3,900 equals 100R, which means R is going to equal 39. If you tried that and did not get that, please ask, and we'd be more than happy to help you. Okay, just 3 last questions here to kind of make you think just a little bit. We want to know, is DE tangent to circle C? Well, if it's tangent, that means that we've got a right triangle. Okay, that would mean that where they intersect makes a right angle. And we'd have our two legs here, and then our hypotenuse is right here. And the hypotenuse obviously is not 2 units long, because that's only the outside part of the hypotenuse. But what we do know is this part from here to here is a radius. And another thing we know about circles is all radii of circles are the same. So if this radius is 3, this one here is also 3. So we know that the whole hypotenuse is going to be 5. So we just need to check, does 3 squared plus 4 squared equal 5 squared? And 9 plus 16 is 25. So yes, it does. So yes, it is tangent. Okay, this time you've got ST is tangent to circle Q, find the radius. This is just like what we just did. So we know that this is a right angle. We know we've got our two legs, we've got R and 24, and then our hypotenuse is going to be R plus 18. Okay, and so that means we've got R squared plus 24 squared equals R plus 18 squared. Okay, you go ahead and pause the video. I'm going to go through this kind of quickly, just so you get the idea again. We have R squared. 24 squared is 576. R plus 18 squared, remember you could box method, or you could R plus 18 times R plus 18, but you would get R squared plus 36R plus 324. And we would find that when we subtract R squared from both sides, they would cancel. If I subtract 324 from both sides, I would get, let's see, 252 equals 36R. If we divide both sides by 36, we would get that our radius would equal 252 divided by 36, which is 7. Okay, let's look here, because this one is also one that we want to make sure we're not getting any confusion on. Okay, this is, our two lines are tangent. They're both on the outside and they intersect at a point out here, which tells me that those two are equal to each other. However, you have to be a little bit careful when you solve this, because when you take the square root of both sides, think back to Algebra 1, x could be positive 3 or negative 3, which means you'd have plus or minus 3. So our answers, there's actually two possibilities. X could either equal 3 or x could equal negative 3, because when you square negative 3 times negative 3 is positive 9. So you could have positive or negative. It can be negative because we are not saying that this segment length is negative 3, because we are going to square it to get that segment length, because you know you can't have negative numbers for lengths of segments. But since we are squaring it, then it's fine. So we would have either 3 or negative 3. And there'll be questions like that on your class kick for today. So just make sure that you're aware that there are two solutions when you take the square root. And like I said, there is a class kick that you need to finish up. So there was day 1 had a class kick and day 2 had a class kick. So just make sure you get both of them done. Good luck.